Assalamu alaikum wa rahmatullahi wa barakatuh. Guys waiting. Okay, do you have any questions before we start? If you have any questions before we start, let me know. No questions? Okay, then we will continue with where we had stopped. We had looked at converting English to logic. We had taken lots of expressions, and the last expression was about lions that we had done. Okay, so with that we will start a new section. It's called nested quantifiers. Nested quantifiers are quantifiers within quantifiers. Is my voice clear? If my voice is not clear, just let me know. Nested quantifiers are quantifiers within quantifiers. So we might have something like this. Okay, so we have quantifiers within quantifiers. So we have three quantifiers together. Okay, so let's take a specific example. So for example, if we have this is so we're saying for all x, where x is a number, there is some y where y is also a number. The domain of x and y are numbers. The x plus 1 y equal to 0. So for all x, so x could be -1, it could be 8, it could be 3, it could be 0, it could be 5, it could be anything. There is at least one y. So is there at least one y for which -1 is true? Very good. Okay, so as Ali Habib says, y has to be -x. So we have 1. So -1 plus 1 equal to 0. Here we have 8 plus -8 equal to 0. So we have at least one y. Okay, for all x we have at least one y. Yeah, 3 plus -3 and so forth. So we have at least one y. Is this clear? Okay, let's swap that and see if it meets the same thing. Okay, there is at least one y for which all of x. Okay, so Qasim says this is true. This is true. Okay, what do you say about this expression in red? Is it true or false? What do you think? Okay, so most of you saying it's true. Okay, so let's look at it. Let's look at it again in a different way. So we say there is at least one y. Okay, Muhammad Ali is also saying both the same. Let's look at it now. There is at least one y. Maybe it's 7. At least one y for which all of x is true, which means 7 plus -1 is 0, 7 plus 8 is 0, 7 plus 3 is 0, 7 plus 0 is 0, 7 plus 5 is 0. Is that true? There is at least one y for which all of x plus y equal to 0. So it is false. Can you think 7 is, I cannot use 7. So is there any other y for which all of x is 0? No. Okay, so do you understand there is a difference? There is a difference. You cannot swap the inner and outer and expect the same results. It's different when you translate it into English, or you will understand, or to math when you try to analyze it. So there is a difference. So you cannot swap the nested quantifier. So that's rule number 1. Do not interchange. Do not interchange quantifiers. So let's move on. I'll give you a very, very easy example. A very complicated looking thing, but very, very simple. I'll give you this is a common question in the exam, a favorite question in the exam. Okay, so you'll have an expression like this, and then you'll be asked negate this expression. The question is negate this expression. How will you go about doing it? So you have to negate this expression. So you have to find the negative of this. So this is, it looks complicated, like, right? It looks very scary. Yeah. Very good, Ali Habib. Okay, so, oh, see, Muhammad Ali has already found the solution. So this is an easy, what do you say, way of getting marks. Very good, Firas, very good. So this complicated question, complicated looking question has a very simple answer. Just change, swap, that's all. That's all. And then this knot, it moves inside, moves all the way, swapping, and it comes here. Okay, even inside, after it appears, so you have a negation of this, so you can rewrite that also. You can say x plus y not equal to y. So this is about 4 or 5 marks in your midterm or in the final. So this is something that you can do it at the beginning. You should be expecting. This is a favorite question among the examiners. So is this clear? You just apply De Morgan's law on each of those quantifiers and then swap the for all to for some and for some to for all, and you get your 3 marks. Okay. Okay. Uh, this is not a nested quantifier question. This is again a translation English um, logic. So there's an example given in the slides. Paul beats up all professors who fail him. Okay, Paul beats up all professors who fail him. I hope there is no Paul in this class. Okay, so how do we translate this into logic? The first thing we need to do is let's come up with some functions. So we need a function, professor. X is a professor. So we can say p of x. This is a function we have. X is a professor. So this is one. What else? Uh, Paul beats up a professor. So we can say beat up function. So Paul beats up X. Paul beats X. He beats up X. Who fail him? Okay, so fail. So we have X fails Paul. So we have X fails Paul, which means X has failed Paul. So this is the first thing you need to do. So you define functions and then you convert it into logic. How will you convert it? So you have if over here, Paul beats up all professors who fail him. So it's like if a professor fails Paul, he gets an up. So we have an if here. Okay, if the professor fails Paul. So if X is a professor, if X is a professor and he fails Paul. If X is a professor and X fails Paul, then Paul beats him up. And this is true for all professors. for all professors. Okay, so this is how you translate from English to logic. The first thing you need to do is come up with functions, and then this is on slide 42. Slide 42. Is this clear? Translating English to logic. Is this clear? Okay. Only the translation, not the Paul stuff. Just forget what Paul does to his professors. That is not important. Okay, then there's another example. All computer scientists are either rich or crazy. So Ali Habib, we have a Paul in the class. Okay, all computer scientists are either rich or crazy, but not both. Okay, so computer scientists are either rich or crazy, but not both. Ali Habib, listen, listen. You can show your things later on. Okay, so a computer scientist is rich or crazy, which means there's an XOR over here. Okay, so if you see there are two solutions there, you can use both the solutions. So the second solution uses XOR. So if X is a computer scientist, then he is either rich or crazy, but not both. Or you can explicitly use operators to indicate rich and crazy. So both solutions are okay. This is slide 42. Is that clear? Okay. Okay, let's go ahead. How do we look at nested quantifiers? Okay, let's jump to slide 45. Slide 45. So we have the domain as real numbers, and we have p of x as x times y equal to 0. So I'll just write it here. So we have px comma y defined as x times y equal to 0.